So let's get started. 10 times 3 over 14 is the same as 10 over 1 times 3 over 14. So before I multiply, let me see if there's anything I can simplify. Well, sorry, let's clear that up, make it look a little nicer. Is there a number that goes into both 10 and 14? Yes, that number is 2. So 2 goes into 10 5 times, 2 goes into 14 7 times, and now there's nothing else I can simplify, so if I multiply across, I get 15 over 7. Well, how many times does 7 go into 15? That would be twice. That's 14, with a remainder of 1 over 7. 2 and 1/7 is the answer. Next question. 8 times 4/5. Well, 8 times 4/5 is the same as 8 over 1 times 4/5. Now, before I multiply, I always want to look to see, can I simplify before I multiply? All right, so that would be the numerator with one of these two denominators. Obviously, everything is divisible by 1, so we don't want to use that. You could simplify this to 8 and 1 forever. That doesn't really help us. So 8 and 1, no. 8 and 5, no. 4 and 1, no. 4 and 5, no. So there's nothing to simplify. So this one we just multiply straight across. 8 times 4 is 32. 1 times 5 is 5. So 32 over 5. Well, 5 goes into 32 6 whole times. 6 with a remainder of 2, with our denominator staying as 5, so the answer is 6 and 2/5. I apologize for the handwriting. I'm using my mouse. I don't have my stylus with me. Number 3 is 4 over 5 times 12 over 5. Well, once again, I have 5 in the denominators in both of them. So that means if I can't simplify one of these, I can't simplify the other one. So 4 and 5 don't have a common factor other than 1. 12 and 5 don't have a common factor other than 1. So in this case, I'd also multiply straight across. 4 times 12 is 48. And 5 times 5 is 25. And for this, I'm actually going to write it kind of like a long division problem because I want to make sure people understand why the right answer is what it is. All right, well, how many times does 25 go into 48? Well, 2 times 25 would be 50, so that's too much. So it's 1 times 25, which is 25, leaving us a remainder of 8 minus 5 is 3, 4 minus 2 is 2. So it's 1 with a remainder of 23. So the answer to this question would be 1 with a remainder of 23 over 25. 1 and 23/25 is the answer. For number 4, 1 and 7/10 times 8/3. Well, for this one, I would multiply, I would change these both to just fractions. So 1 and 7/10 would be 17 over 10 times 8/3 would just remain 8/3. And before I multiply, I want to see if there's anything I can simplify. Well, 17 is a prime number, so nothing's going to go into both 17 and 3 or 17 and 10. But I see 8 and 10, they're both even, so I know 2 is going to go into them. 2 is going to go into 8 4 times. 2 is going to go into 10 5 times. So when I multiply across, I get 17 times 4. Well, 17 times 2 is 34, so double that would be 68. And it's okay if you need to, go off to the side and do the multiplication. It's okay to do 4 times 17. 4 times 7 is 28, carry the 2. 4 times 1 is 4, plus 2 is 6. There we go, that's how I got 68. So 68 over 5 times 3 is 15, so 68 over 15. Well, how many times does 15 go into 68? Well, if I count by 15s, I get 15, 30, 45, 60. So it's 4 groups of 15. 4 times 15 is 60. And my remainder then is 8 over 15. All right, once again, 15 goes into 68 4 whole times. That is 60. 68 minus 60 is 8, so that's my remainder of 8 over 15. Number 5 is 7/12 times 4 over 5. Now, I can do this without simplifying, but I'm going to end up with a big number and have to simplify it at the end. So might as well simplify before I multiply and see how much easier this problem will be. So 7 is a prime number, so can't simplify 7 with anything, but 4 and 12, well, they're even, so I know 2 goes into both of them, but if you think about it, 4 goes into both of them also. So 4 goes into itself once, 4 goes into 12 3 times. Multiply across, and you're going to get 7 times 1 is 7, 3 times 5 is 15. So the answer to this question is 7 over 15. For number 6, I once again need to change this to a fraction. No mixed numbers for multiplication. 1 times 12 is 12, plus 1 is 13 over 12 times 4 over 5. All right, before I multiply, let's take a look. Can I simplify anything? Yes. 12 and 4. I know that 2 goes into both of them because they're even, but I know that 4 is a bigger number that goes into both of them. So 4 goes into itself 1 time. 4 goes into 12 3 times. And when I multiply across now, 13 times 1 is 13. 3 times 5 is 15. 13 over 15 is the correct answer. Once again, I apologize for my handwriting. I don't have my stylus. I'm doing this all with my mouse. For number 7, 2 3/4 times 1 3/8. All right, well, let's change these both to fractions greater than 1. 2 times 4 is 8, plus 3 is 11, so that's 11 over 4, times 1 times 8 is 8, plus 3 is 11, so 11 over 8. Okay, now this might be a little tricky to some people because they see 11 and 11 and 4 and 8. They're like, oh, there's some factors here. But actually, there isn't. 11 and 4 can't be simplified. 11 and 8 can't be simplified. Obviously, 11 and this 4 can't be simplified. 11 and this 8 can't be simplified. So we would multiply across. 11 times 11 is 121. 4 times 8 is 32. So this particular fraction can't be simplified. And I'm going to tell you right now, it's ugly. It's an ugly fraction. All right, so let's do a little long division here. How many times does 32 go into 121? All right, let's count by 30s. So 30, 60, 90, 120. So 4 times 30 is 120. But if I do 4 times this, it's going to be, yeah, 121. It looks like it's going to be too much, so I'm going to try 3. 3 times 2 is 6. 3 times 3 is 9. If I subtract here, 21 minus 96 is going to be 25. All right. Now, for people who say, well, how'd you get 25 so quickly? I kind of thought of it this way. If I go from 21 down to 100, right? From 121 to 100, that would be subtracting 21. And then I have to go down how many more to get to 96? so down another 4. So 21 and 4 is 25. That's one way to do it, or you can do the, standard algorithm, which is can't do 1 minus 6, so I'm going to borrow and regroup. So this becomes an 11. 11 minus 6 is 5. Can't do 1 minus 9, so borrow, regroup. This becomes 11. 11 minus 9 is 2. It doesn't matter how you do it. The answer is 25. So let's go back to what this means. This means 32 goes into 121 3 times with a remainder of 25. I apologize for my handwriting. I'm using my mouse, not my stylus. 3 with a remainder. Ugh, that is ugly. 3 remainder 25. What does that mean here? Answer is 3 and 25 over 32. All right. This had some big numbers and lots of steps. I get it. Yeah. All right, next one. Excuse me. 2 and 3/5 times 2 and 1/4. Well, 2 and 3/5 is the same as 13/5 times 2 and 1/4, which is the same as 2 times 4 is 8, plus 1 is 9, 9 over 4. Is there anything to simplify in this problem? There actually isn't. 13 and 5 can't be simplified. 13 and 4, 9 and 5, 9 and 4 can't be simplified. So once again, we got an ugly big number to deal with. All right, we'll be all right. 9 times 13, I'm going to go off to the side. I'll call this my scrap area to do that. 9 times 13. 9 times 3 is 27. Carry the 2. 9 times 1 is 9, plus 2 is 11. So this is 117 over 20. All right, well, let's count by 20s. 20, 40, 60, 80, 100. That's 5 groups of 20. 5 groups of 20 gets me to 100. My remainder is 17, so 5 and 17 over 20. That's the answer to number 8. So, number 9. All right, these I expect to be a little bit of a, I want to spend some time on these. First of all, if the area of this entire figure, it's asking for the area of the striped portion. If the area of this entire figure is 1, and if you look at it, it's broken down into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27 pieces. So just by looking at it, 1 out of 27 are shaded in, okay? But I want you to understand the math also behind this. This way, let me draw this. This way, it is broken down into 3 equally sized groups. So this would be 1/3 right there, right? So 1/3, 2/3 this way, 3/3 this way. So 1/3 broken down this way. Looking at it going up and down, so if I look at pieces that are this way, oops, sorry, I'm got to work on my neatness. This right here, imagine if I drew that nice and neat, right? Well, how many of these are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is shaded here is one of the 9 pieces that look like this. So this would be 1/9, 2/9, 3/9, 4/9, 5/9, 6/9, 7/9, 8/9, 9/9. One of the 9ths is shaded in. So hopefully that visual helped you see it. So this is 1/9 shaded this way. let's write this at the bottom. So the intersection is where 1/3 times 1/9 is shaded. So 1/3 times 1/9 is equal to 1/27. 1/27th. All right. For this one, I want to point out a couple things before we start counting and answering. This is, each square below is 1 square unit. All right, so and we're looking for the area of the stripe shape. So if you look at it, this going down here is 1/4 of 1 square. 2/4, 3/4, 4/4. Okay, so that's 1 whole. Another 1/4, another 2/4, another 3/4, another 4/4. That's another 1 whole. So this is basically 2 shaded squares. Sorry, 2 squares total, not shaded. So how many fourths are shaded this way? 1, 2, 3, 4, and then 1 over here. So if you think about it, 1 whole thing is shaded plus this piece, which is a fourth. So that's 1 and 1/4. Or another way to think about it is, I'm going to erase this piece now, is from here to here is 1 and 1/4, or 5/4. This way, I'm going to shade this in green now. Just see, oops. This will be much easier with a stylus. This right here would be one third of a square, another third of a square, another third of a square. So, right, so 1/3, 2/3, 3/3. So how many of the thirds are shaded? Well, 1/3 plus another third is 2/3. So this way we have 2/3 shaded. So the answer to our question of what is shaded in this particular case would be 5/4 times 2/3. So let's do what that is. 5/4 times 2/3. All right, I'm going to, normally I would simplify this, but I want you to kind of see it the way it is. So I'm just going to multiply straight across. 5 times 2 is 10, and 4 times 3 is 12. 10/12, which normally I would simplify to 5/6. All right, the other way I would do it, I might as well show you now, is 5/4 times 2/3. Apologize again for my handwriting. I don't have my stylus. 2 and 4 can be simplified. 2 goes into both. 2 goes into itself once. 2 goes into 4 twice. So when I multiply across, my numerator is 5 times 1 is 5. My denominator is 2 times 3 is 6. So 5/6. So either one of these answers is the correct answer. 10/12 or 5/6, they mean the same thing. But I do want to kind of go back to this image and discuss with you a visual way for you to see this answer. And that is, one of these squares is broken down into how many equally sized pieces? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So 12 is our denominator. This one is also broken down into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 equally sized pieces, right? So together, the whole thing, this is one whole piece, this is one whole piece, if we counted everything shaded or unshaded. But how many equally sized pieces out of that are the size of 12 are shaded? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There are 10 equally sized pieces out of 12, right? So imagine if I kind of moved this piece down to here, and I move this piece down to here, right? What you would see is 10 out of 12 shaded, 10 twelfths, which is also equal to 5/6. I know it was a long explanation, but I kind of wanted you to be able to see it, visually and also multiplying. All right, for 11 to 14, without actually solving each problem, write the expressions in order from least to greatest value. All right, well, what do I see in common here? I see 3/14, 3/14, 3/14. Every one of these has 3/14 multiplying it. All right, but this one, let's underline in purple, is being multiplied by 2. This one's being multiplied by 2 over 2, which is 1. And this is multiplying by 1/2. So if you think about it, if I just ignore these 3/14, what am I multiplying by? Well, here I'm multiplying by a number less than 1, so that's the smallest. Here I'm multiplying by just 1, so that's next biggest. And here I'm multiplying by 2, which is bigger than 1, so that is the largest. So it's C, then B, then A. Essentially, what you're doing is looking at, and maybe I'll circle them, because 3/14 is common to all of them, what am I multiplying by? Well, where I'm really comparing 1/2 to 2 over 2, which is 1, to just 2, which is 2. So in order, this is smaller than this, which is smaller than that. So CBA is the order. For number 12, what is in common with all three of these problems? Well, 2/3, 2/3, and 2/3. So those are in common. So now we have to really kind of figure out, what are we multiplying by? Well, I'm multiplying by 1/8, 1/2, and 3 over 2. So let's talk about 3 over 2 first. This is a fraction less than 1. This is a fraction less than 1. This is a fraction greater than 1. So if I put these in order 1, 2, 3, C has got to be the biggest because I'm multiplying by a number that's greater than 1. 1/8 and 1/2. Well, which one of these is bigger? What would you rather me give you? 1/8 of a pizza or 1/2 of a pizza? Yeah, half of a pizza is bigger, so this one would be in the middle, and this one is the smallest, so it would be A, then B, then C. Once again, the most important thing to see is, what am I multiplying 2/3 by in every single one of these cases? And that will tell you the order. That's how you can do these problems without actually doing the solve. Number 13. These have 1/8 in common, 1/8 in common, 1/8 in common. So we are multiplying 1/8 by 2/3. That's a number less than 1. 3 over 2, that's a number greater than 1. And 3 over 3, which is equal to just 1. So which one is the smallest? Well, it'll be 1/8 times the number less than 1, which is A. Then the next biggest would be times 1. 3 over 3 is 1, so that's C. And then next would be times the number that is bigger than 1, which is B. So A, then C, then B. Finally, for this section, we are multiplying 6 in all three cases, all right? We're multiplying 6 in all three cases. We're multiplying it by 5 over 5, which is just 1. We're multiplying it by 5 over 6, which is a number less than 1. And we're multiplying by 6 over 5, which is a number greater than 1. All right, so 6 is in common for all of them. So it's really about, what are we multiplying by? Well, B is the smallest because 5/6 is the smallest of the three numbers we're multiplying by. Then A is next because 5 over 5 is equal to 1, so it's BA. And then C, we're multiplying 6 by a number greater than 1, so that would be the biggest. So it's B, then A, then C. Hope this helped. All right, now to the word problems with the tables. All right, the following information is in tables to answer questions 15 to 20. It's going to be the same table for all of these. So the table shows the number of hours 4 students practiced to prepare for a math test. Look closely at the labels. Answers must be in simplest form for full credit. All right, labels meaning hours, minutes, whatever it is. In this case, it's hours. Ricky is 1 3/5 hours. Mickey is 1 1/2 hours. Molly is 3/10 of an hour. And Holly is 1/8 of an hour. What is 1/8 of the amount Ricky practiced? Well, of 1/8 of something means you're multiplying 1/8 times the number of hours Ricky practiced, which is 1 3/5. All right, let's extend the page here. That means 1/8 times 1 times 5 is 5, plus 3 is 8, 8 over 5. So 1/8 times 8 over 5. Now I can simplify before I multiply. So 8 and 8 simplify to 1 and 1. And I multiply across and I get 1 over 5. The answer to this problem is 1/5. So that's 1/5 hours is what the answer to this question is. All right, next question is basically asking us, how much longer did Ricky practice than Mickey? Well, Ricky minus Mickey gives us what we're doing, right? If somebody practiced longer than the other person. So it's really 1 3/5 minus 1 1/2. All right, so let's talk about that. 1 3/5 is equal to 8 over 5. Minus 1 1/2 is equal to 3 over 2. Once again, 1 times 2 is 2, plus 1 is 3. All right, at this point, I need a common denominator. So the good common denominator used for these two would be 10. So 8/5 is equal to, well, I double 5 to get 10. So 2 times 8 is 16. I multiply times 5. So I multiply 3 times 5, I get 15. So I get 16/10 minus 15/10. 16 minus 15 is 1. So it's 1/10. So how much longer did Ricky practice than Mickey? It's 1/10 of an hour. Number 17, how long did Molly and Holly practice together? Well, together means I need to add these two numbers. So I'm adding Molly, which is 3/10 of an hour, plus Holly, which is 1/8 of an hour. All right, to add fractions, we need a common denominator. In this case, common denominator I would use is 40. So for the first fraction, I multiply 10 by 4 to get 40. So I would take 3, multiply that by 4 to get 12 40ths. For this one, I multiply 8 by 5 to get 40. So 1 times 5 is 5. Add them up. My numerator becomes 17. When you add up fractions, the denominator stays the same. 17 40ths of an hour is how long they practiced together. Number 18 is asking us, what is 3/5 of the amount of the time Molly practiced? Once again, the of means multiply. 3/5 of Molly's time. So 3/5 times Molly's hours is 3/10. Well, can I simplify before I multiply? And it turns out, no, I can't. 3 and 5 can't simplify. 3 and 10 can't simplify. I can't simplify the 3's here. I can't simplify them here. So I multiply straight across. 3 times 3 is 9. 5 times 10 is 50. 9 over 50 is the answer. Number 19. Which student practiced the most? All right, well, we can eliminate Holly and Molly. They're out because they're less than 1. So the question is, Ricky or Mickey? Well, kind of answered this in the other question, but they both begin with 1 whole, right? And what's a good common denominator for 5 and 2? So that would be 10. So Ricky is 1 and double 5 is 10, so double 3 is 6. 1 and 6/10. Mickey is 1 and 1/2, which would be 1 and times 5 for the denominator. 1 and 5 times 2 is 10, so 5 times 1 is 5, so 1 and 5/10. So what's bigger, 1 and 6/10 or 1 and 5/10? The answer is 1 and 6/10. So the student that practiced the most is Ricky. And the final question. Multiply Molly's hours by 60 to calculate how many minutes she practiced. So it's basically just saying take her hours and multiply by 60. All right, 3/10 of an hour times 60, or 60 over 1, would tell us how many minutes she practiced. All right, let's talk about that. Before we multiply this, well, 60 and 10 have a common factor, the 2, 5, but I would use 10. 10 goes into 10 1 time. 10 goes into 60 6 times. So my numerators are 3 times 6, which is 18. And denominator is 1 times 1, which is 1. So 18 over 1 means she practiced for 18 minutes. All right. That's the answer, but I do want to, for people who want to hear a little bit more, if you think about it, 10 means divide into 10 equal pieces, right? So if I took an hour, so 60 minutes divided into 10 equal pieces is 6 minutes for each one of them. But she didn't practice for 1/10 or 2/10. She practiced for 3/10. So 3 groups of this 6 minutes, while 3 groups of 6 is 18 minutes. So it's just another way of thinking of the problem. But it basically kind of just said to you, if you multiply her hours by 60, you get the minutes. I hope this video helped. Sorry for the handwriting.